In this video, I'm going to be talking about global illumination, or the short for GI. Okay, so in Maya, there are two types of lighting condition. So there is direct lighting and there is indirect. Now, in this first picture, I have direct lighting condition, meaning that I have a light source, which is here, and I have my subject, which is a table, and this light source is actually point directly into the subject. Okay, so as you can see here, the light is actually placed directly on top of the table, and that's why all these will be lit correctly. Alright, whereas in this example, in the second picture, I actually rotate the light upward. Okay, meaning that you will not have a direct illumination from this light as compared in the first picture. Okay, but rather you're relying on the bouncing around part from that light. So for example, if I have this light here and I have my blocker there, this light will go to the ceiling and it will bounce around to the wall and it goes to the table. Okay, so that's why the name is indirect. I didn't directly illuminate this table, but rather I'm relying on the bouncing around of that light. Okay, now the GI actually referring to the bouncing around portion that is happening in your lighting scenario. Okay, so in real life, the light is a very complex subject to calculate, and if you try to do a very realistic light, it's very difficult to achieve in that kind of realism. Okay, so this is when the GI will help you to render that kind of realism. And again, as mentioned, so if we have a light source on the top right here, this is just a scenario that what would happen in your lighting environment. Okay, so maybe part of the energy will go to this wall and it's bounced to the sphere, or maybe some of them will go to the floor directly and it goes back up, and maybe it will go to this green wall and it bounces back to the sphere. Okay, because all the energy is very complex and it's very randomly happening in a real life scenario, and Redshift is just an engine that's trying to mimic that real life scenario. Okay, so again, this is just a render without GI turned on, and you can see like this portion of the sphere, it's very dark, right? And the same thing here, it's very dark, so it doesn't really resemble what would happen in the real life. Now, with the GI turned on, you can see like things are starting to get real. Okay, and if I go back, right, see how the energy is bouncing around. You can see like there is a bit of like orange here, a bit of green there, and maybe a bit of like this white coloration at the bottom of the sphere. That's because, like, again, in real life, the light or the energy from the light that goes here, it will take a bit of orange and it goes to the sphere and it will make this portion a little bit orange, and same thing with this green wall, it will take off this green color and it will give this part of the sphere a little bit green. Okay, same thing with the floor, and those creating this nice vibrant image. Okay, GI it's can be quite slow when it comes to rendering, but it will give you a nice like accurate result as compared to no GI. So this is something that you can consider when you do your rendering. Okay, GI usually used often when it comes to interior rendering. Alright, again, because it will bring the realism to life. One thing that you have to keep in mind when you want to do a GI rendering, make sure the scale is set to meters, because there are some calculations that GI required to be able to render the scene correctly. Okay. In Redshift, there are two types of GI setup. So they are using like primary GI engine, and they're using the secondary GI engine. Okay, so let's talk about the first one, the primary GI. Okay, so we have like 3 different types. So we have the photon map, we have the irradiance cage, and we have the brute force. Okay, so I'm gonna go back to Maya, and I'm gonna go to the rendering setting, go to the GI. Right, by default, this is what you will get. Okay, no GI, and if you render, you'll get something like this. Okay, so no GI, and the result usually is pretty dark. Okay, so I want to pause. Okay, so the first one is photon map. Again, photon map, it's an old method, right? So the way it works is that it will shoot out the energy coming from the light. It will goes there maybe, so all the energy that is being shoot out are shoot out randomly. Okay, some of them may go to the floor and so on and so on. Okay, so if you want to use this old method, right, you have to go to its light properties, okay, and scroll all the way down and make sure the GI is turned on. Now again, as mentioned, this is pretty old technique and require like guessing value. Yes, you have to kind of guess the value because you have to type and you have to render, make sure everything is okay. So sometimes like it's too bright or not enough photon, so you have to kind of like revisit all these value again. Okay, so I did like a bit of photon map technique, right? So this is what happens if you use photon map technique. So all this little dot is actually energy that is being shoot at from the light itself. Okay, as you can see, like the picture is not very good. Okay, that means like you have to put more photon, but again, the more photon that you put, the longer the rendering time going to be. Okay, and again, this first attribute indicating that you can make the photon brighter. Okay, so each dot that is being shoot at from the light will become brighter if you put a higher value. Okay, so again, like the photon map can be quite tedious if you're not experienced, right? But you have more control to it. Okay, so moving on, we have the irradiance cage, right? So the way it works is that you can activate it by choosing this option, right? So there is not much setting for you to do. Okay, so the way it works, it will just shoot out the photon again, right? But rather than doing it manually, right, Redshift will kind of like calculate its surrounding. It will guess like what color its surrounding are supposed to be, right? And it will shoot out this randomly, and it will kind of like calculate its surrounding, and maybe this surrounding, right? And it will create like this image. So let's do another render. Radiance and render. Right, so everything is done automatically as compared to the photon map. Okay. And again, I'm gonna stop, and if you scroll down, there are settings for you to kind of like change. Okay. Now moving on is brute force. So the way it works is the opposite way of photon mapping. So rather than light shooting its energy, Redshift will actually calculate the energy from the object surface back to light source. Okay, and along with this random bouncing. So if I go back to Maya, you just need to set these to brute force, and it will do the job for you. Okay, again, you can control like the brute force value by putting it here, right? Okay, so I'll stop this. Okay, so brute force is a new technique. It can be quite slow, but the result can be pretty accurate. Okay, and you don't have to deal with guessing proportion of the photon, because Redshift will do the job for you. Okay, so that's primary GI works in Redshift. Okay, again, this is just some comparison on how each method works. So if you use photon mapping, you have more control, right? And because you have more control, you can set the number like quite efficiently. But the downside is that it's outdated, and you have to do a lot of like work of the guessing of that photon, right? And the processing time and the storage may becomes to waste, right? If it's not visible to the camera. Okay, this is something that you probably want to read yourself. Okay, moving on, I prefer to use brute force for my GI rendering. Okay, because it's pretty accurate and there is no flickering, and it's very easy for me to tweak. Okay, but the downside is that the brute force can be quite slow method to render. Okay, because it is automatic, and Maya, or Redshift rather, will do the background work for you. Okay, moving on. Some people are comfortable using Irradiance Cache because it can also produce like smooth image, right? In some cases, it can be like quite faster than the brute force. Okay, something that you can like play with. Okay. Again, the downside of Irradiance Cache is that you cannot use the IPR to see, and it's much harder to control. Because again, if you look at the setting for Irradiance Cache, it may not be easy to understand, right? So that's why like I prefer to set up to the brute force method. Okay, you just need to control it from here. Again, we're gonna move on to the secondary GI. Most of the time, the secondary GI is set to Irradiance point cloud, right? Because its purpose is to provide faster and cleaner secondary lighting to the primary engine. Okay, so if I go back again to Maya, I usually set this to Irradiance point cloud. And again, it's very simple for you to set up, right? You just need to put how many bounds should be happening in the scene. So the secondary GI act as a support to the primary. So if the result is not clean enough, you may want to put like the secondary GI. Okay. And again, like by turning on the secondary GI, it will make the brute force and the Irradiance Cache render faster and cleaner. In some scenario, this technique can be quite long to render. Okay, so again, when you are doing the secondary GI, you have to compare the result. Okay, sometimes like you put the GI right to Irradiance Cache or maybe to brute force, and the result is not much different. Okay, but the rendering time goes up pretty high. So as lighting artist, you have to kind of balance between your rendering time and the result of your rendering. Okay, so again, this is something that you should read yourself. So one thing you have to keep in mind when you are doing the secondary GI is that it only provides a benefit when multiple bounds are needed. So if the scenario contains lots of light, or when the lighting conditions are difficult. So if you're rendering, so if you have a lot of light and require like very complex scenario, then you probably want to put the secondary GI. Otherwise, you turn that off. Okay. And one last bit is that this is my typical setting when it comes to the GI rendering. So I put my primary engine to brute force and the secondary to Irradiance point cloud, and I set my bounds value to 2 or 3. Okay, usually more than 3, it's cannot see anyway. Okay, that's not much difference. Okay, so that's all about the GI.